So let me show you one more example of the abstract class, and for that I need an inheritance. So I'm just declaring here one class, and the class is father. Before you move into the abstract, you must need to understand the concept of overriding. So what is overriding? Let me explain first. For example, I have one class father and another class that is child, which extends from father. So you can say there are two classes. The child is the subclass of the father. Let me save this program as that is inheritance demo 11.java. Now, see, there are two classes. One is the father, another one is the child. Now, child is extending from father. Now, father has a function that is void prayer, in which the implementation is there, and that is what father is regularly doing the prayer. Now, father wants that my child also do the same thing. So there is a one function, and that is available in the child also, and that function is child is regularly doing the prayer. So same function name with the same type signature available in the parent class, that is the same thing available in the child class. It is known as a method overriding. Now I have one class, and that is inheritance demo 11. Now I want to write a main method over here. Now first let me declare what are the rules and what child can access and what father can access. So you must need to understand what that child can access all the properties of father except the private member. So child can access all the things except the private members. But what father can access? Father can access only overriding method of the child. So this is really interesting. It means father cannot access the own property of the child. For example, this child has one more function, and that function is a singer. Child is a singer. So child has a one more function, that is singer. Here I am writing system.out.println. Child is a very good singer. So this is, you can say, simple a two class. One class, that is the father, another one is the child. Child is extending from the father. Now what father can access and what child can access? So suppose if you create here an instance of child, c equal to new child, then this child can access the function of father also, as well as their own function. For example, c dot prayer. If you write c dot prayer, then you will be able to access the function of child only, because the same function is available in the child. If you write here c dot singer, then child will be able to access his own function. Let me compile this. Java C inheritance demo, and that is 11.java. Let me run Java inheritance demo 11. See here, child is regularly doing the prayer and the child is very good singer. The both function child can access, even child can access the function of the father also. For example, if I am writing here that the super dot prayer, then child can access the super prayer function also. So if you run this, then you will get the message that the father is regularly doing the prayer, child is regularly doing the prayer, and child is very good singer. In short, you can say that child can access all the property of the father except the private. In short, child can access this function, as well as child has accessibility of their own function also. But what child cannot access? Child cannot access the private member of the father. But what father can access? Let me put here comment so you people can get the better idea. What father can access? For example, if I'm writing father f equal to new father, then father can access only their functionality f dot prayer. then father will be able to access the function that is father is regularly doing the prayer. So if you run this, you will get the message that the father is regularly doing the prayer. But if father is pointing to child, and that is a new child, so if father is pointing to child and if father is calling the function f dot prayer, then father will be able to access the child is regularly doing the prayer function also. Here, two times it is coming just because super dot prayer is also called from here. So let me put here comment and let me run it again so you can get the better idea that the father can access the child function also over here. Why? Because it is method overriding. Now, father cannot access the functionality of the child which is not overriding. For example, if I am writing f.singer, then this is the functionality of the child, that is own functionality of the child that cannot be accessible by the father. So father cannot access the functionality which is not given to the child. Why it is accessible over here? Just because method bindings at the runtime, and method is binding at the runtime, and that is the reason why the father can access the property of the child runtime. But variable binds at the compile time. For example, if I have one variable I is equal to, that is 100, the same variable is available with the child, that is integer I is equal to 200. Now you can say this is variable shadowing. It means the same variable that is available in the father, the same variable available in the child, that is known as a variable shadowing. And students, remember always that the variable is binding compile time. So variable is binding compile time. It means if you call here, that is a system dot out dot print line f dot, and suppose if you access the variable I, then it will not print the value of the child, it will print the value of the father. If you call this, if you compile this particular program and if you run this, then you will get the 100, you will not get the 200. Why it happens? Just because variable is binding at the compile time. So even if the same variable is available in the child, father cannot point to that particular variable. But method is binding at the runtime, so same method name is available in the child, then father can point to that particular method. So father can, if you put here comment, then you will get the better idea. Let me put the comment and let me run this program again. So now you can see that father can access the function of the child runtime, but father cannot access the variable of the child runtime. Why? Because variable is binding at the compile time and method is binding at the runtime. Now, in which situation the abstract is need to be implemented? Suppose father want that the functionality that is available with me, that must be implemented by my child. So if you want to do the overriding compulsory, at that time you can declare your method as an abstract. So your child have to override that particular function. So let me write some rule over here. Whenever you want to make overriding compulsory for subclass, then you may declare method as abstract. So whenever you want to do, and that is you can say that I want that my child how to override the function that is prayer. Right now what happens, see, if a child is not overriding the function prayer, if child is not overriding the function prayer, then if a father is pointing to child, if a father is pointing to child, then father can access the function of itself. Then father is regularly doing the prayer. But here you can check that the child is not doing the regularly prayer. Now father wants that the child must do the prayer. So if father wants that the child must do the prayer, at that time father can make his method, that is a prayer, as an abstract method. So you can say, if you declare method as an abstract, then class must be abstract. Vice versa is not true. So I want to declare here this method as an abstract. Now one more rule is, abstract method have no body. Abstract method cannot have body. So this is, you can say, curly braces is known as a body. So you can remove this. So abstract method cannot have a body. If you declare method as an abstract, then class must be abstract. So I need to declare this my class as an abstract. One more thing that you need to remember, and that is what? We cannot create an instance of abstract class. So abstract class cannot be instantiated. So here you cannot create the instance, that is father f equal to new father. This is not allowed. We cannot create an instance of abstract class, but we can create a reference. So I can write father f equal to new child. So this is allowed. This is a reference of the father which points to the child. So here you can call the function, that is f dot prayer, and I don't want to access now this f dot I. So here you can access, that is f dot prayer function. Now if a father is pointing to f dot prayer, but this function is not implemented by child, then you will get an error. So let me compile this particular code. You will get an error, and that is what? Child does not override the function prayer. Now child have to declare the function prayer. Child have to do the prayer. If child is not doing the prayer, then compiler will not allow you to execute the program. See here, child is regularly doing the prayer. So in short, you can say child have to implement the functionality of the father, right? Now this class have one more child. This class have one more child. You can say child number 2. Now child number 2 is not doing the regularly prayer, right? Then definitely you will get an error. And this child 2 is not a singer. This child 2 is a cricketer. And you can say child is a very good cricketer. Now this father has the 2 child. One is the child which is regularly following the rules of his father. But this child is not doing the prayer. Then what happened? Then you will definitely get an error that this child, that is the child number 2, is not an abstract and does not override the method prayer. Now in which situation this child is allowed? If this child assures that I am not doing prayer but my child will definitely do this, then you can declare this class as an abstract. If you declare the class as an abstract, then it will not give you an error. Now all the class which is following this child 2 have to override the function, that is prayer. Why? Because this is an abstract class. So what is the rule? Rule is non-abstract subclass. How to implement overridden methods from abstract superclass. So this you have to implement, right? So this prayer function, this child has followed the rules, but this child is not following. If this child is not following, then this class must be either abstract, or if you don't want to declare an abstract, then you have to then you have to implement the prayer function over here. So let me write here, this is prayer function. And you can say child 2 is also regularly doing the prayer. Now what is the biggest benefit? The biggest benefit is father can point to his child anytime. So father can say f equal to new child 2, and if father says that f dot prayer, then father can access the functionality of the child. So let me compile this and let me run this so you people can get the better idea. See, both the child is doing the prayer. But in which situation you are allowed to not to write the function that is as an abstract. So let me remove this. If I am remove this, then I have to declare this class as an abstract. And remember student, if this class is an abstract, you cannot create an instance of child 2. If you compile this, then you will get an error. And the error will be what? That is child 2 is an abstract, cannot be instantiated. So this father cannot point to even child 2 also. Now which class have to implement the functionality of prayer? All the class who are the sub child of this child 2. Right? So let me write here class, for example, child, and that is you can say sub child extends from child 2. So this subchild is a child which is non-abstract, and if it is a non-abstract, then definitely you have to override the function that is a prayer. One thing. Second, here you can create an instance of subchild. So father can point to subchild. So if you compile this, you will get an error is what? Subchild is not an abstract and does not override the function in the father, and which is which function? Prayer. This class is an abstract, has not implement the functionality. So all the non-abstract subclass have to implement the functionality, and this class have to write the function that is void prayer. And I can write here that subchild is regularly doing the prayer, and hence it is the non-abstract subclass. You can create the instance of this. So I can create the instance of this and I can point to that particular class and I can get the result, and that is what? Child is regularly doing the prayer, subchild is also regularly doing the prayer. So in short, you can say that this subchild is the non-abstract subclass, and non-abstract subclass have to override all the functionality of the abstract superclass, and that is you can say this prayer function is not implemented by this child 2, so this class have to implement. But if this prayer function is there in a child 2, if this prayer function is available in a child 2, then this subchild no need to implement any method. Why? Because it is already there in the father, and child can access the functionality of the father. So if you cut from here function and if you compile this program, then there will be no error and you can access the functionality that the child is regularly doing the prayer. Here this child is the call from this abstract, that you can say child 2 is regularly doing the prayer. Child 2 and subchild is regularly doing the prayer. So here you will get the message child 2 and subchild is regularly doing the prayer. But since this class is the abstract, this prayer function, if you are not writing, then this child have to write, and this child can also write the same message that the subchild is regularly doing the prayer, and you will get the message over here that the subchild is regularly doing the prayer. Now sometimes father wants that some features must be inherited in the child and some features must not be inherited in the child. In short, you can say that, see, whenever you want that all the child must do the prayer, then you can declare your method as an abstract. And whenever you want that some functionality that my child must not do, some for example bad habits, generally what happened, father wants that the good habit must be there in my child and my bad habits must not be there in my child. So this father has the function that is void smoke. So we all know this is the bad habit. So I'm just printing here, it is a bad habit. So definitely a child have the functionality of the father. So child can access that the father is doing the smoking and this is the bad habit. But if child is also doing the same, then it is very dangerous. If child is also doing the same, then it is very, very dangerous. So child, definitely it is also doing the same. Father, definitely it is also doing the same. So what happens, see, if you create an instance over here that the father dot prayer, the same time you can access the functionality of the child that f dot smoke. So child is also doing the smoking. Child is also doing the smoking and it is a bad habit. So I don't want that the child is also do the same thing. In short, to promote the method overriding, you can use the abstract, and to restrict the method overriding, you can use the final. If you declare your method as a final, then child cannot override the function. If you declare method as an abstract, child have to override the function. So the wonderful thing is what? Whenever you want to make the overriding compulsory, you can declare method as an abstract. And whenever you want to restrict overriding, then you can declare method as a final. So if you declare method as a final, if father is declare method as a final, child cannot write the function that is a smoke. So if you compile this, you will get an error. Child cannot smoke. Why? Because the overridden method is final. So what child can do? Child can do nothing. Child can just see that my father is doing the smoking. Child can just see that my father is doing the smoking. Child cannot do this. See here, if father is pointing to child, and if you call the f dot smoke, then it will simply print that this is a smoking method of the father. This is not the method of the child. So father, it is a bad habit. It is a bad habit. Child cannot write the functionality over here. Even this child also cannot write the function void smoke. If this child is writing the same, then also you will get an error. The overridden method is final. So you cannot write here void smoke. Can this subchild can write the function void smoke? Can this subchild can write the function that is void smoke? No. Why? Because in hierarchy, father has declared it is a final, so none of them child can do the same. None of them child. Even the child of their subchild. See here, this is child 2 and this subchild is the child of a child. So you can say this subchild is that is a grandchild of the father, then also you cannot do the smoke. You have to put comment over here. Then and then you will be able to compile the same. You can say that abstract is used to promote the method overriding and final is used to restrict the method overriding. So what happened in reality? In reality, you can say that the good features of any system are always abstract, and the bug of the system are always final.